I think I understand the southern flights a little bit more than I used to. Uh, Once I understood what ground speed is and indicated airspeed, and once I got that all down, then it made a lot more sense to me. I mean, here's what we have to know, just so you can kind of see where I'm going forward with that, is if you just think of the southern flights and the fact that there is about, I don't know, 2,500 miles is a guess, difference between, let me bring up a flat earth map, just so we can look at it together, but you'll see, oops, that's not what I wanted to do, there we go. And I'll just kind of show you what I'm talking about, because once I kind of realized this, then I was like, oh, okay, I get it now. That's a good one. Okay, so we're going to be looking at this image here. Down. Okay. So when you're talking about Australia to Chile, and we know that Max Egan took that flight, took him 11 and a half hours, and the miles on that flight is 7,000. Okay. So doing that distance, if we get a little calculator here, and we say they went 7,000 miles, and we divide that by 11.5, okay, we get 608 miles per hour, okay, which makes sense. That's about what planes go. We know that, so everything seems to jive, right? Yet, other people have shown that there are, and I guess we could show this too, might as well, while we're here. If we go to earth.nullschool, we're going to figure out if there's any jet streams that those planes could be possibly getting into. Another thing that we've changed, I don't know if people know this, but when you get to this site, it used to be right on the azimuthal equidistant. Now when you bring that up, it actually starts with Australia in the middle. I'm sorry, Antarctica in the middle, which is just funny because it didn't used to do that until flat Earth started being talked about. You have to kind of flip yourself your own little map here. Okay. So when we do this, all of a sudden things start looking a little bit more like they make sense. So we're doing wind, and then we're going to go height. Well, in between 250 and 700 is the jet streams, or is about 35,000 feet. 250 is about 32,000 feet, and 70 is about 45,000 feet. So, it'd be nice if they had like a 150 in here, but they don't. So when you look at these jet streams here, remember we were talking about a flight going from here out of, Australia. I can't really see where it's at now. Hello. Okay, over here. Oops, right about there. Okay, so it's coming this way. We know that they're circling this way. And if you catch some of these winds, that's 166 kilometers per hour, 186, 203. Oops, that's too far. Getting over here, we got 147, 201. And this is like too much this way. Are we there? Okay, and then if you go even higher, so let's go up to the 70 here, then you can see you've got winds at 116, at 100. Okay, so you've got now here even higher, you've got even more. Okay, and this is probably around 45,000 or higher though, but you've got 153, 165, 177, 151. These ones here are flying around. And these are the polar winds. And the southern polar winds are year-round. They're not as variable as the middle is. And so what you've got now is, here's what we got to believe. We just found out that there is definitely air currents going. So what is more plausible? That the plane is going 608 miles per hour and is not having any wind? We just saw that all the wind is going in that direction. So if you believe in trade winds, which everybody should, because that's how planes fly and that's how they cut time, and that's why planes going generally in an east direction are faster than coming west. So if you believe that, then what is the reason the plane is only going 608 miles per hour? What you have to believe is, let's say that those planes are going 150, or there's 150 mile per hour wind. Well, then you have to believe that that plane is actually going only 450, because that's what it means. When you're being carried by the jet streams, that only can be measured by ground-based tracking or GPS or with known distances. So what I'm trying to say is, if this was actually 2,000 miles longer, okay, so let's say this is a much more vast area, that all you would need to do is get that plane up there and going a little bit faster, and nobody would ever know. Not the pilot, not the people who are tracking the plane, not the people flying in the plane, not the passengers, nobody. Because there's nothing to tell you that what's happening. Basically, we know that they can add that 150 miles per hour to that speed. And again, if you take that, let's just take 150. So if instead of 608, now we add 150, now we've got 758 miles per hour. And then you can times that by the 11.5. And that's just, now you've got 8,717. So now you've got an extra almost 2,000 miles, 1,700. And that's a, low estimate. And again, that 11.5 hours is a quick flight for that way. And then going back, it takes 14 hours, which makes sense. We just saw that the jet streams are usually going the other direction. So really just something that I think I've changed my mind on before. I was a little bit confused how that all worked, but now it's like, well, wait a second. Either I have to believe that the plane is going a lot slower than it can go because it doesn't affect, the speed of sound when you're being carried by the wind, because the speed of sound, you would break the sound barrier if you're cutting through the wind at that speed. But if you're being carried by any trade winds, you just set the plane to 0.95 Mach and go. So either you have to believe that the plane is going 450 for some reason. I don't know why. No planes go just cruising at 450 for some reason. And then letting the jet streams pull them up to 600. Or the plane is really going as fast as it can, probably 650, plus an additional 150 miles per hour that makes up that distance. Again, the reason this would not be known is because if all they can base it off of is ground speed. So it's basically how much distance is the plane covering in a certain amount of time. Well, if there's a deception there, nobody would know. You just have to accept the fact that the plane is actually going 450, being carried with winds, and for some reason the plane doesn't maximize its fuel efficiency and actually get up in the winds and go as fast as it can. It just feels like cruising. I don't believe that, and I think that's the answer. That if it were true that and there's a lot of people out there that think southern flights disprove the flat Earth, and actually the southern flights prove the flat Earth. So, or at least evidence towards it. So, amongst many others. So let's go back and see if there's any more chat here. What was I saying before we got on that? I took a diverge, didn't I? I was going to check if anybody had any questions. I see people punching in questions on ask.fm. I'll get to those after. Let's see here. So what is hilarious? You can't just say it's hilarious. It's hilarious that people question where they live when they're given no evidence. That's what's hilarious, I guess. They probably do cancel the flight when the winds are low. I wouldn't doubt that. Again, here's another thing, is if it was real, the distance was exactly like we're given. People say, how could you question the distance? It says it's 7,000 miles. Then show me a cruise that goes from New Zealand to South America. There isn't one. Well, there is if you go up to Japan and up to Alaska and around down by, California and then down to the South America. But where's the boat that goes straight across? Well, there's not one because boats are not like planes. Planes can have the variance we just talked about of 200 miles per hour that nobody would really notice, but a boat cannot go more than 20 miles per hour. Sure, if it's got a current with it, maybe it's going 24. If it's going a little slow, it's going 18. But a cruise ship cannot make up that distance in the amount of time. They would be 5 days overdue. So